Welcome to the last couple of lectures for ISO 541, and the handout that you've received is kind of called the Job Shop Lean Simulation. And fundamentally, the whole idea of lean in job shops, at least the way I've developed the method, fundamentally says that if your layout is badly chosen, if you have not arranged your equipment appropriately, you will always be unlean, and you will always be conducting all these, low impact improvement events without really addressing some of the root causes, which is that you did not align your equipment as per the logical material flows that your product mix demands that those equipment should have. Okay, so I've given you a handout and briefly go over some of the things which we will try to cover. So fundamentally what we have is 12 machines, that's a so-called job shop, okay? And we would make about 16, 17 different products. And each product has a routing. I'll give you some more details about that. But as far as trying to show what this game is trying to teach you, as far as what facilities should do besides just putting machines together, one of the things that you must do is something called product mix segmentation. Understand how your products differ in the value they bring when you sell them, in how much work is involved to make them, in the quantity in which you produce them. So you need to segment your business. You can't just go into facility design by not understanding that your products are different. And the criteria could be the quantity in which you make them, the profit margin you earn for them, how complicated they are to make, how often does the client or customer order them. You need to understand that. Second thing I would try to talk to you is something about product mix rationalization. Maybe in this game, and maybe in the course projects that you did, this doesn't come out too well, but you do not design a layout, a facility layout, by just working with all the products given to you. Okay, you cannot just say, well, I took all the products, I designed the layout, and gee, my problem is solved. Part of the problems you may be having is not being able to say no to your customers. So that is called product mix rationalization. You rationalize and you say, don't think we'll make these products next year. Customer, madam, sir, why don't you go to our competitor next door? We'd rather you screw their happiness than us, because we have quality issues, we have setup issues. Our suppliers who support this particular product, we don't trust them. Ta-ta, goodbye. That's another thing which you do. So the concept is that you just don't design a facility layout. Even before you design the layout, you start asking, should we design the layout to even make these products? Okay, that's another thing which you would do in a lot of factories. Product mix rationalization. Third thing, of course, is facility layout. Now, we've gone to the textbook solutions, right? We've said process layout. What's a process layout? All equipment of the same type will be in one area. Cellular layout, well, you organize the cells into families. But what we forget is that there is a spectrum of potential layouts in between those. They are far more flexible, and they combine the properties of the cell layout on one side and the process layout on the other side. We kind of forget that. So that is also important to understand, especially because in a lot of factories, you will have expensive machines. And if you have two product families, each of them requires that machine, you're out of luck. You cannot buy another one machine and put one each in those two cells. Then you have monuments, I forgot to turn this on, so maybe it's for the better. So you have monuments sometimes which you have to worry about. Third thing is material handling and shop floor control. Now, we talked about this concept of the water strider. Now, the water strider, unlike a material handler, is what I would call a superior person, in the sense that a material handler just looks at a pallet, a container, and moves it. They look for a traveler, they check where it has to be moved. They just go put that stuff in some other location. They don't really care about what they moved, where they moved it to, and when they drop that tub or container off, in what order, in what sequence. They don't really care about many of those details. As a result, there's a lot of waste. The machine operator comes and says, oh my God, this part has been put in front of my machine. I don't need this one, I need that one. And then they go and find another handling device to rearrange those pallets and then prioritize the work you do. So the water strider is somebody who has much more awareness. It's almost like they're a junior plant manager. They have full view of what's going on, and they have the authority to actually do things like equipment operation, work in process sequencing, and other business-oriented actions which typically the material handler does not have the authority to do. So I've taken the liberty of being that water strider, mainly because if there's chaos, I know kind of how to kind of get the game back to running sensibly. Cross-training. We tend to believe that a person who runs a machine 8 should run machine 8. We believe that a person who runs machine 2 must run machine 2. Inspection just does inspection. They have no authority to do scheduling and control of workflow. I think that in a layout context, in this course's context, it's important to understand that the way you design the layout could impact what you train people to do and which people you choose to be multifunctional. So I think in today's lean, flexible context, it's very important for you to understand that people may not just continue with the way HR originally recruited them. Maybe we need to change the way we train people, change them to be able to perform functions that are complementary. So for example, logically, when you look at the process flow, the routing of a part, you might probably want to train somebody to do the work in operation 10 and operation 20. Not necessarily in operation 10 and operation 40, because then they lose control. Their work at operation 10 gets sent to somebody else. That somebody else's work gets sent to somebody else at operation 30, and then that work comes back to them at operation 40. They pretty much lost ownership of the work that they were doing. So in many cases, the way you train people should conform with the way the product flows consecutively to multiple process steps. Okay? Then of course, finite capacity scheduling. We haven't covered that much in this course, but probably there's more of that in the other course, 542. But you've also got to understand that the layout helps somebody to schedule their shop correctly, as also the schedule, if not correctly done, you might have the best layout, but people will be working on the wrong work in the wrong priority. Okay? So what this game is going to try and do is, in the context of a facilities planning problem, try and show you all these other support systems, skills, functions that also need to be firing on all cylinders, or else you don't really make money. You're not profitable, you're wasteful, which means you're unlean, and you have extremely high overheads, you're paying too much overtime. All the sins of not being efficient kind of bubble up to the top. So that's this is job shopping. If you want further information about what all the stuff is, you can go to these websites. Next, please. So let me introduce you to the game. Next slide, please. So here's our goal. Our job shop is about making money fast. Okay, so our fundamental objective is cash flow, move our money, mom. You can talk about waste elimination and all that good stuff, but fundamentally what I feel is waste is cost, and that a business exists to maximize sales in the shortest amount of time. That's what we call cash flow. So the way it's typically measured is, whenever you ship an order, the value of that order will get added to your booty, and then you say, well, this much money was earned, and this was how much time it took for that last order to complete. So total money earned divided by total time taken, that's your cash flow velocity. And this metric will keep on getting upgraded, and then finally you'll see how the shop functions. That's the other fundamental goal. You do not want orders to be locked out as work in process, or being reworked, or waiting in queue inside the facility. And a fundamental metric that measures the speed with which any order flows through the shop is flow time. Okay? Cannot forget that. So the layout design, a lot of what we've done in this course pretty much is attacking this, but the economic justification is coming from this metric, cash flow. Okay? Then, most important, each of your machines is going to have a responsibility. You will be Xing out certain squares. All I ask you, please, is be diligent. You don't have to rush it. You might hate your job like most people do in industry, even in academia, but just take your job seriously. Kindly, when I ask you how to conduct your operation, just keep a note that you've got to X out these boxes. Okay. So that's really our goal. Okay. Now, what's our facility all about? Pretty much you've got 12 machines. Okay? Now, in practice, these could be departments. You could have 2 machine 8s, 3 machine 7s. We'll keep it very simple. What I'm basically saying is there are 12 types of capabilities. Rachel, could you push yourself a little bit more to the right of August? Yeah, do a little bit more, just separate. Okay, now, that's all you pretty much do. Please check that the work which came to you has had the previous work done, okay? So let's say the routing of a part is 1 to 4 to 8 to 9. If you find, and I'll do my best also to help you, if you find that machine 1 hasn't X'd out its operation boxes, and here you are getting work because you're machine 4, just raise your flag. Hello, got a problem, okay? So to that extent, just be diligent, that you cannot be a grinding machine and get a rough forging. You blast your machine apart. Grinding machines require you to first remove most of the metal off the raw stock, and then you kind of finish off the part. Okay, so that we should know that all layouts are designed around sensible choice of process flows. Most choices aren't sensible, unfortunately, and that's why what you have are badly designed workflows in most layouts. I'm the smart material handler, so this, well, not necessarily smart, but the idea is a water strider. Like I said, the water strider is an opportunistic material handler, a multifunction person supporting multiple areas of the facility, doing different responsibilities. There's one thing I really took away from the Toyota Lean, knowledge base. It was this role, very powerful role. Okay, so pretty much I'll be the one releasing the work to the shop. I'll be the one moving work between the various machines. And I'll be the one expediting. And you'll also see probably that, the water strider picked the wrong job to pick up first. And that's true. In badly designed layouts with poor communication, no display boards, no schedule, pretty much people do first in, first out. They execute whatever is immediately in front of them, regardless of whether or not that work was on the schedule with an immediate due date. So you will see that really, most of the time, I'm kind of just winging it in the first run of this game. And that's the whole idea, that I know that you might say, well, in round 1, you purposely disadvantage the system. It's okay. But you will see that as you design the layout, you start controlling and eliminating all those reasons why big factories are screwed up. Okay? Now, finally, receiving shipping are Greg and Sachin. Thanks to Sachin and Brian, he's not here, Brian, but they wrote like the performance metric calculator. And what they're going to do is they will just accept a finished part and dutifully say good part. Now, if I really wanted to make you guys think, I could have Greg say, no, these X's were not correctly done, there's a quality problem, sorry, this shipment is rejected, no money to your bottom line, shame on you. Okay, but he'll be nice. Okay, the point again is that I am not focusing on quality during this game. Why? Because quality is number 1. You cannot pass on bad work to the next operation, period, okay? And that's why what people do is they train employees to inspect their own work, to be responsible, and not have inspection as a separate department in the facility. That is reserved typically for government mandated, or customer mandated inspection. It has to be done, and you typically require expensive equipment kept in one area. Okay, in those cases you send inspection. You send work for inspection to those areas. Otherwise, decentralize, put inspection at source, where the work is done. Okay? So they'll inspect the parts, they'll record the time when each order was completed, and then they'll update the metric. And you will see that little metric, the performance curve, will keep recording as the system progresses. Okay? Okay, so here's what we have. These are your jobs. Okay? These are your jobs. Now what you have really is, you have about 17 such products. That's what's called a part number. Okay, there are about 16 different part numbers. Each of these parts has a routing and a job content. Keep in mind again that I'm not teaching you how to design the layouts of assembly lines. There are a lot of non-assembly facilities, and one of the biggest characteristics of those facilities is, one, the different products don't have the same routing, the sequence of processes they go through. Secondly, even if they did have the same sequence of steps, the work content in different operations may not be equal. So let me explain that to you. This is part number one. Its routing is, first it goes to machine 1, then it goes to machine 4, then it goes to machine 8, then it goes to machine 9. Okay? Then, look, what is this 24? This 24 is the work content. It's like this machine is gonna X out 24 boxes to represent the fact that they did some work on this particular part. When I take the same batch of parts to machine 4, they will look in their operation column, there'll be 9 empty boxes. They will X out those 9 boxes. Okay? Then I'll take this to machine 8. There, he or she will see, they will also have 9 boxes to X out. Then finally, I'll take that part number 2, machine 9. They will have 18 boxes to X out. Point is that in practice, this work content is often influenced by the changeover time for that job on the machine, the cycle time per piece, and then the lot size. How many pieces are you making for that particular batch? So, to give an example, look here. You see the quantity and the volume? What you're being told is that part number 1 has a lot size of 2. So, here's what the machines will have to do. I'm going to travel to machine 1. Since I have no clue where the machines are, I'll come here to Kendra. Okay, she's machine 1. What she will have to do is, look at the top here. It's a lot size of 2, which means that there are 2 sheets of paper. Each sheet of paper represents a piece. Okay? So there are 2 sheets of paper. Part number 1 is made in a lot size of 2. There's 1 sheet of paper, it's made in a lot size of 1. If there are 3 sheets of paper, it's made in a lot size of 3. And you might say 100. Well, just say I'm nice. You don't want somebody Xing out 50 boxes on 100 sheets of paper. You pretty much quickly have no volunteers to play the game. Okay? So what Kendra will do is, she will be machine 1. Okay? She'll have these 24 boxes. She'll X them out. Then she checks if there's a lot size of 1 or more. If it's more, flips the page over, X's out another 24 boxes. Okay? Then she pretty much just drops a part of here. Okay? I'm the water strider. I'll walk up and say, oh, I want to be busy. So I say, Next step is machine 4. I'll look for machine 4. Don't gesture, let's play a very disadvantaged system, right? I appreciate it, nice gesture, but don't. In the first version, don't tell me anything about where you are, okay? So, the point again is that, see, in the real world, people don't have communication systems in place, they don't have visual electronic signals in place which tell them this machine's available, or the machine's busy, the machine's broken down. So I, the material handler, simply looks up and says, hey, I see something to be picked up. I just pick it up, it goes to machine 4. I drop it off at machine 4. Machine 4 is broken down, person's taking a restroom break, lunch break, they're already committed to 2 days of work. How did it help me to drop this part into their queue? That's how the real facility works. So when you change the layout, you actually eliminate this nonsense. So for example, when you go to manufacturing cells, each work center is in close proximity, they communicate to each other. I'm ready for work, I'm not ready for work, taking a break, etc., etc. So I bring this over to machine 4. Stacey Ann sits and says, I'm machine 4. She checks that machine 1 has had its work done. She's machine 4. She has 9 boxes to X. There's a lot size of 2. She herself flips over page and X's out the 9 boxes because she's machine 4. Once that's done, she drops it off here. That's it. Okay, then I'll bring her some other work. If she's fine that she has work to do, and machines 4, the next thing to be done, she does the work, okay? So like this, I want you to keep in mind that really what matters is per piece in the batch, depending on the batch size, the total value of shipping that order, well done, on time, varies. And now many cases people use profit margin. It's kind of a harder concept to model in a game. What we basically say is cash flow is driven by which of these higher value jobs you complete. That's all. Cash flow is measured by which of these higher value jobs you complete. Okay, so please, as the machines, kindly be a little diligent about Xing out the squares corresponding to your machine. And also, if you find that I have delivered to you a product that has not had its previous operations done, shame on me, you smacked me across the head. Just figuratively speaking, don't do it really, I suffer concussion. Okay, good. Next slide, please. So, for all the machines, this is what you should work with, okay? This is going to be the route sheet. Now, when you get a route sheet, kindly check for batch size, kindly. Okay, if you see a staple or a paper clip, that will indicate 2 to 3 pieces in your batch. So please be diligent and check for that. So therefore, look for this number. This is typically how people describe individual pieces, 1 of 2, 1 of 10, 2 of 3. They're trying to keep count on the piece count. So first of all, check this number. Then, that's your operation sequence. That's the machine assigned for each operation. Please don't confuse between the first column and the second column. Okay? This is important. So when you get your part number in front of you, kindly check first of all that if there's something to be done in front of you, that person or machine did its job. Okay? Now, be forgiving if you find that somebody has messed up the Xing. For now, we'll skip it. In the future, we could kind of get more sophisticated and sort of call out after every round, call out the team and say, shame on you, machine 1. You messed up 2 batches of parts. Shame on you, machine 9. You killed 1 part, like that. You can always play that game. The idea is quality is number 1, period. I personally don't feel it necessary to emphasize that if you don't do your work diligently, you don't deserve to be running machines or managing a shop. Okay? So there'll be 2 sheets like this. So typically look for a staple or a clip, and that will tell you that you have a batch more than 1. And then, depending on the machine you are, you'll have these boxes to be extra. Okay? Next slide. Okay, so here's the thing. Remember we talked about quality? No, seriously, these are examples we've seen. These are examples we've seen in practice because people are like, why? For example, work content. Some machines get a lot of work to do. I mean, they are overloaded. And no consideration is given by the management when they run their Kaizans, their improvement effects to say, hey, we should eliminate the waste of over-processing selectively on the work that people do. Okay, so everybody does 5S, it's wonderful. Everybody does cell production across the board. What you would like is, which products are going to be impacted by which improvement event? Okay? So those people who say, oh my God, 90 squares to X are, hey, I'm out of here. That's what they do. This is unacceptable. So remember, we said pride of work, power. It's serious. It's serious. At Toyota and Honda, for example, the psychology is, I don't want my customer to be unhappy with the quality of my work. Remember for underwear, Hanes underwear, they had that ad once inspected by inspector number 12 or something. It was serious that this underwear has been lovingly sent to you by somebody who actually checked that this underwear deserves to go on your butt. That's how it works. But that was the point, that this tag in the bag is an indication that we care. And that really matters. That really matters. So please, do not take these liberties. Do not just run a line across each row. 10 operation ticks done. Do not do all the stuff. No blacking out and stuff, right? You're not evaluating a course and blacking out SEI circles. You're not doing that, okay? This is what counts. This is what counts. Just please be diligent. Okay, now this is a performance curve. Now, if you do scheduling, this measure is called weighted completion time. You may have seen that in your inventory models also. It's the time value of money. How is it computed? It's like a running total. It is like a running total. As I complete a batch and I deliver it to shipping, and they log in and say job was done, the program has automatically got the total value of the batch. For example, take part number 1. Each piece is valued at $100. There are 2 in that. So when I complete this particular part, at whatever time it's completed, $200 are added to your kitty. You've earned $200 more. But see, what it does is, as every order is shipped, it recomputes the velocity of money flow. Meaning that, over time, between this operation and this operation, what changed was the total value of money earned, and this total time it took to complete that next order. So over time, your business is recording a variable velocity of earning. as each job is shipped. So what you would really like is, for a good company, this curve should be steep and to the left. So for example, you see this empty patch here? This is what a lot of companies do. They have no schedule and they follow the classic value stream mapping. Empty the queue at the end of the shift. Why? Why? Because when the next shift starts, it starts cold. So at least maybe 30 minutes sometimes, there's no work in queue because the material handler has just come in. They are finding out from production scheduling in their production meeting what jobs need to be moved. Sometimes shops run empty for a period at the start of the shift and at the end of the shift. So what you would really like is, of course, we don't have it here in this case, but what you would like is this warm-up period should be short. And you would like big bang jobs run immediately. Okay? And what you would like is this entire curve you would like to be short. Why? This is this time when the last order completes is called the make span. A very powerful parameter in any scheduling project. So what you would like is steep curve, shoot to the left. And you will find that as you move work to the shop faster, through layout configurations, maybe through correct sequencing of the work you do, this curve goes from being a very shallow curve to a sharp. So that's an example. This is an actual example. This is an actual simulation we played. This is an actual simulation we played. Initial, improved layout, better improved layout. And so as people learn what were best practices, they themselves responded. So this is what you would like a company to show. So again, this is my bias. When I do lean or whatever, I don't jump in and say Kaizen, waste elimination. I just don't. My metric is cash flow. Okay? Thereby what happens is the 7 types of waste, it may essentially become cost and lean. If you read the goal, if you drill a little deeper into a couple of production control books which have chapters on theory of constraints, there are like 3 metrics that Goldratt puts forward. Maximize throughput. The goal of a business is to make money. Okay? It's not to eliminate waste. It makes money by eliminating waste, but the goal is to make money. So maximize throughput, meaning fulfill the orders in the books, in the backlog. And then get more sales to jack up sales, okay? Maximize throughput. Second objective is cut inventories. Finished goods are the highest cost, work in process the next highest cost, and then raw material the lowest cost. So the goal is don't hold finished goods inventory, have a minimal amount of work in process. If you have to hold inventory, hold that at the raw material level. It should not take you much time to get the job done the moment the order comes in, okay? So that's the second objective. And then the third objective Goldratt says is, you are in the business of making money by cutting costs. And that's where all this popular hype, waste elimination, lean kicks in, okay? So personally, I'm a bigger favorite of the theory of constraints from a strategic planning perspective. When you start looking at how do I do things, I think the TOC guys don't tell you much because they make money as consultants. Toyota, thank you to them, have essentially told us how to go about making some of the changes to achieve these 3 measures of performance. What I think Goldratt forgets, that I think Lean has taught me, Red has taught me, is morale, safety, okay? Respect for humans. As I work with the smaller companies, like tier 2s and below, I find that sometimes the owners of these companies are the biggest culprits of why their companies are screwed up. Seriously. I know what's right. For example, one company, it's a Navy supplier. We're trying to apply lean there. The president is very good, but her thing is hot list management. She manages by hot list. Now when I said, but then you don't have a schedule, don't tell me that. We will manage by hot list. So what happens is, nobody has overall schedules to work at. So they lose traceability of order. Then suddenly out of the blue, a job hits its due date and the customer calls and says, hey, where's my job, right? Suddenly that job's become white hot, super hot, red hot, orange, hot hot. So I've heard this on the hot terms, right? It's like people are holding baked potatoes in their hands. See, but that's the issue, that you don't run a shop by firefighting. And you cannot say it's a small shop, we can't afford to be improved. You cannot say that. But then that's the thing, that if you don't trust your employees to have the brains, if you don't even ask them, hey, inspection is the bottleneck. What can we do to increase throughput through inspection. Well, stop sending me hot lists because you keep disrupting my setups. And so I lose time between setups. And then I was doing something, I had to stop doing that, and then I had to come back to that 2 hours later. I screwed up, I made a bad part. So managing by hot list typically comes from the president, the ownership. That's all they know. Hey, the customer's angry. What did you do? Get fixed, right? So respect for humans, I think, is something which the TOC guys don't really dwell on. Maybe now they do because they're competing with the lean consultants. But I think in the Toyota system, if you look at historically where things came, one of the pillars of lean and Toyota is respect for humans, besides operations and tools and production plan. Right? So I think add to that safety, morale, ergonomics, employee feedback schemes, because the goal is some of your best ideas might come from your employees. That doesn't mean that people, industrial engineers like you, don't have a strategic role. You please don't forget that there's an opportunity for you to even get good feedback and buy it for your ideas from the employees. Okay? So the point again is that you will find that as the layout changes, as you start becoming better coordinated, performance of the system will improve. Okay, so we're going to play round one. Next step. Okay, so we designed a process layer, right? So question to you, how would you design a process layer? How would you design a process layer? I mean, if I said, well, we have these products, they have their routings, they have production lot sizes, given all these software tools you've been taught, how would you design a process layer? For example, you see me having just arranged the machines in some configuration. I would call that a U configuration. There's a central aisle, material handling aisle, and I've got the departments on either side. How do I design this? How would I arrange this configuration of 12 machines? Again, I'm trying to sort of review the entire course, so please don't hate me, but I'm hoping to kind of bring together a lot of what I've taught you, methods, solutions, ideas together. So how do we design a process layer? I've got 12 machines. Yes, obviously.
Maybe make a from-to chart,
Good.
then a flow diagram.
Good.
And
Okay,
based
good.
off the largest flows.
Absolutely. So basically what you do is, you take the routings of all these parts, you have the lot size, so either manually or using something like FAST, you create the from-to chart. In this case, it's the Q type or the dollar type from-to chart, how much money is moving between them, throw that from-to chart into Storm, arrange like a U-shaped grid, and something comes out. Okay. Then we select a shape. At this point, let's keep it U. Okay. Important. In this first run of the process layout, you will be a process layout. No signaling, no saying, me, I'm machine 4, I'm machine 9, oh, I'm ready for parts. None of that. You do the work given to you, check its quality, just put the part in front of you. Let me be the one who moves the work. That's a classic process layout. Machine operator, the departments don't care. They just get the work, they process it, they leave it. Okay? Next slide, please. Okay, and then what's important is there's no one-piece flow. You cannot yank this sheet off. You can't do that. Okay? You're in classic batch production. Why? In a process layout, huge distances separate equipment used consecutively. Because you're using big containers and you're in batch mode, you're basically in a batch and queue mode of production. You cannot, just because you are close here, you cannot say, I finished one bucket. Here, start this batch. You can't. Don't take that liberty, okay? Next slide, please. So, familiar? That's the from-to chart you got. Next slide, please. Whatever linear layout you got, you fixed the in here, the out here, you've gone for that. Next slide, please. So this is like a grid layout. Okay, this is like one of the grid options. So again, please note that I've actually gone ahead and tried to give you good solutions, but purposely, we have not designed the shop based on any logic. Why? Almost every company I've talked to doesn't have any of these methods available. Okay, so many of them buy equipment. Where's this place there? This place in that corner. Put the machine there. Okay? Seriously, facilities aren't designed with much analysis work, and most of the time the projects are given to architects. Architects have a superficial industrial engineering knowledge about how layouts should be designed. They use something called bubble diagrams, and that's classic design. Okay? So, next slide please. So this is basically the U layout. If I were be smart about designing a process layout, I'd have the central material handling aisle. Now just looking at this diagram, I went through the motions of using Storm, create the linear arrangement and bend into a U. Is this something you would implement? Or just looking at this visually, the flow diagram, thick arrows moving long distances, does this indicate to you that even the process layout could have been smartly designed? Anybody? I ran through my motions, right? I use the computer software, right? I just take this computer software output and I implement the solution, right? No, no. You massage it. Because the software doesn't replace human experience. So, looking at this U layer, if we were going ahead with this arrangement, first of all, you know that you have not been arranged correctly. But really, just because the U shape is a popular shape that all the gurus of lean talk about, would you go and implement the U shape in this arrangement or something else? What would you want to do? What would you want to do? Anybody? What would you want to do?
You have to play around with different layouts and see, you know.
What I'm saying is, remember a picture is worth 1,000 words? Looking at this flow diagram, which is telling you the thickness of, the thickness of the arrows, giving you how much money is moving between 2 points in this layout. Could you immediately take a decision that, you know what, I'm not going to have a U-shaped arrangement, I have to go with something else? What would that look like, potentially? Well, what could that look like? What could that look like?
Shift 4 and 7 in the middle, bring 11 down.
Exactly.
Shorten the arrows.
There you
Have
go.
a hybrid.
There you go. That's the idea. Relax this mindset that the U shape is always the one to go for. That's the first thing. Secondly, hybrid. The point is that it is very feasible for you, even today, to say, you know what, I might want to combine equipment from 4 and 7. I might create what I call partial cells. I can't have a complete cell, but at least let's cut out all the delays and wastes that occur, because today I'm still moving 100 feet between something done in 4 and then something done in 7, right? So potentially you could have like a U shape or a W shape. That's the point, that great for the computer output, great, nothing against it, just please don't buy in, just because you use some package, that this shape is what you go for, okay? But the point again is that the computer model is giving you a logical basis compared to what we did just now, okay? Next slide. So this is a little bit later. This is a little bit later. We didn't cover this. You will do this more in 542. But the point again is, see, in the typical manufacturing facility, how much work these jobs put on the various work centers varies. It's completely unlike an assembly line. It's completely unlike, and that's why, again, please, a lot of what you'll be learning about lean is coming from one domain, assembly line manufacturing. The biggest problem there is that they are balanced. Their facilities are designed for takt time, they're balanced for flow. This is what you'll find in a lot of situations. So, you could even right now, if you were thinking about improving the layout, you could come back and say, hey, can I buy a machine 4? Can I, for example, buy a duplicate machine of 4 to help Stacy? Do I need to buy another machine 7 to help Dania? Do I need to buy another machine 10 to help patient? Or, see, what happens is typically, people look at these unequal loads. They look at certain overtime loads and say, you know what, we need to pay more overtime. We need to buy more machines. Work harder. What they don't ask is, are we over-processing? That's one of the wastes. Over-processing waste. So what happens when you get such profiles, you go back and say, hey, which are the products that are being processed at these machines? Which of those products have a very high work content compared to the work content of other operations that those products go through? And then you go through a design for manufacture analysis. You go through an equipment capability analysis. And you come back and say, you know what? I can cut down, I can reduce how much work I have to do on the products which go on these heavily loaded work centers. So again, that's the point, that just don't jump in and say layout design because Professor Ryan taught us a course. Ultimate goal is balancing, reducing the workload, cutting out the waste, and keeping cash flow as the ultimate objective. Next slide. So that's it, okay? So I know I may have bored the hell out of all you guys. Now comes the part where you can sort of hopefully observe and keep a small piece of paper in front of you if you wish. I will ask you, tell me anything which you think was bad or good about the way we ran this first round. Because the first round should show you everything that is bad about bad facility layouts, especially layouts which have to make a high variety of parts. Okay. So, quick question to all of you. Quick question to all of you. As machines, are you comfortable with what you have to do? Any other questions? Okay, I'm ready to go for it. Tell me when you're ready. Huh? Go. Okay. You're walking down the mountain, she comes. I'm sorry, I know that this is not a repetition. That's a long set of TV. Oh, there's some more work for you. Another batch of parts. Enjoy. There's another batch of parts for you. Enjoy. There you go. I'm just jamming. It's push, jam it through just in time. Jam it through. One. There's nothing. Enjoy. There, machine 6. Don't tell me who you are. Don't tell me that. Enjoy. There's another batch of parts. Machine 3, I'm going to find you. I'm going to find you. I always find my man, my woman. Machine 3, machine 3, machine 4. Enjoy. Machine 4, machine 11. Of course, it won't be this uncoordinated in a real factory. They'll at least know where they're going. But do you see what I'm doing? I'm just putting a first in, first out sequence on the work. I couldn't care less in what order I'm putting the work in front of a person. And that machine operator also doesn't ask me, what are the due dates? Are there any priorities you wish me to execute? Just give me the work, I'll just do whatever you give me. So when people are moving in big containers and they just drop in a random sequence, the person just says, what is the easiest to reach and get? And from there starts the evils of the badly designed factory. Oh, stop. Enjoy. So, I see something ready. I'm nearest to it. I pick it up and I say, machine 4. Machine 4. I give it to Stacy and she's like, hey, I'm busy doing work, don't bother me, I'll get back to you. So I pick up this, I'm nearest to this machine, I see some of it, they put up a flag, I have to go to machine 5. So I come to Marcy. Anyway, you can notice that she's not been sweeping her floor, setting up SPC standards. She's like, I'm just waiting for the work because that's all I've been paid to do. Okay, no problem, okay. Now I'm just waiting around. I drive my forklift over. Oh, I see some work. Let's keep it up. Machine 4. I just go jam some more work in. No due date sequence. There's already a pallet in front of me, so I just put this behind that. Okay? This is first in, first out. Then I go pick up something. It's a batch, okay? I just put it together, no priority sequencing. I just pick up something and I give it to the next machine. Then I go, I just pick up something here, I come here and I say, aha, machine 7. This one I know for sure, so I bring it to machine 7, enjoy. Okay? Then I come back here, so across the aisle, I just pick up something, machine 2, there is car. All these people were not doing any continuous improvement work, setting up standard worksheets, nothing. They were like, okay, just run the machine, we're going to run it. In the meantime, I'm just, machine 8, lot size is 2. Enjoy. Nearest, okay, this is dispatching, nearest table first, okay? Machine 4. There, I'll give it to Stacy. Machine 4. Okay. Then I come across the aisle. I pick up machine 6, which is over there, compressor. I just give it to him. Again, he's working on something. Take more work. You're busy, take more work. So already I'm creating a queue there. Then I pick up something here. This is machine 4. Machine 4 needs more work. So boom, she gets more work. By the way, machine 4, 96 operations. She's not going to be a very happy person, okay? That's it. And it will show soon in her face, okay? Okay? Now, I pick up 2 jobs, right? What she finished first, she put down. What she finished last, she put up. I pick that up and I bring it. What she finished last, I'll put in first, okay? That's machine 4. And I give it to her, a paid work center already. So that's a heavily loaded work center. What could I care less? There's machine 7, there I go. I didn't bother to pick up something, I'm just doing a one job at a time thing, so I pick it up here. Because my forklift truck can't hold 2 loads, so I come back here, you need to move something, I give it to my favorite overload work center again, there you go. Okay, then I come back here. I don't have a tugger, so I can't pick up multiple jobs, right? So again, what was finished first at the bottom, what was finished next on the top. I pick up the stuff off the top, I pop the list, and I just find some place, I jam this job in here, out of queue, okay? Machine 7 is there, I give it to machine 7 here. This guy's been waiting, I don't have any counter, I pick up this job. That was waiting, who cares, okay? Machine 8. Machine 8. Good. Machine 8, bring it here. Then I come to this one, that's machine 9. Ooh, he might have the same fine labor job. So machine 9. You see there are underloaded work centers, guys just sitting around, that's how the shops work. Okay. Machine 5. Go. Again, I have a choice, right? That guy's been waiting, what do I care? I just say, let's be nice to the overloaded work center. So I go machine 7, and I bring it to machine 7, and I jam it here. Okay. They look around and say, oh, something nearby. Let's go to machine 9. Machine 9. Thank God there's something in queue, so I don't have to travel empty coming out of this machine. So I pick this up, batch of 2. Whoa, we have a quality problem.
I had to work for so long, I forgot the rules.
He was tired, he smoked something he shouldn't have. That's a hole! Oh, we have a sale. Okay, but this would have been a payment for this. Okay, congratulations, we finally had a sale. Enjoy. Now, where am I? Okay, here we go. I pick this up, okay? So now that's machine 7, and this is machine 6. Okay, now, I could have gone this way to cut my distance or travel, but no, I'll be inefficient. So I go to drop this off 7, I give this off to 6, okay? Then, I come across here, I have no line of sight, no communication, no onboard VoIP audio connection with anybody. I have no idea what's going on. This is machine 2. This person has not bothered to help this person. They haven't been charged with any responsibility. Hey, I'll just stick around, I'll get paid, and then enjoy overtime on top of that, okay? Then I'll pick up here. We have a shipment. We have a shipment. We have a shipment. We have a shipment. I ran over some people, I was over speeding with my forklift, but that's okay. Yeah, that was okay. Again,
Go to 1 page.
machine 8.
And,
You might have to see. So what I'm saying is, hey, I can look good. I'll give this job to them first because that's one operation left. So I waste time. Oh, this machine 8 against me. God, this is more work for you. Okay. Then I take this one. This is machine 10. Beep, 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 beep. Ran over a couple of people. Doesn't matter. They cover number insurance. So here it's not. Machine 7. Machine 7. I put it out of sequence purposely. Yeah.
I'm about to file.
Then I'll give machine 12. Okay. Okay, machine 12 has some work finally. I'll give machine 7 some more work. Okay. Then I'll look at this one here. Machine 10. Oh, be careful. Oh, yeah, there we go. Machine 10. Okay, nearest neighbor service. You notice, no knowledge of scheduling, no idea what due dates are. I'm just doing my job. I see a load near me, pick it up, put it someplace, okay? This is machine 7. I drag it through, more work. Then I come across to here. We have a sale. So, I could have shipped this, I didn't have any idea. I get this to shipping now. Okay? Then I come out here, pick up these jobs again. Q2, this is machine 9. Come here, I travel this far, machine 9. Then, this is complete. Machine 8! Where did you go? Where did you go? Where did you go? Okay? Now, so, these screws up, we enjoy life. Okay? Good. Okay, there you go. Okay? Yeah. Okay. Then, I'm nearby, I came out of shipping, oh, I'll pick up some jobs here. Machine 12, ah, you're busy. Machine 4, oh, you're very busy here. There we go. Machine 4 is done. Machine 7, ah, let's move on to you. I don't ask anybody. I don't ask anybody. Are you ready for the work I'm sending you? How many days of queue do you have? Is your machine running? I don't care. I just move the stuff, and this creates a big burgeoning queue, and the orders get penalized because they get carried at 18% lending rate with no value. This is machine 6. I should know my layout by now. I don't have short sight. 6. Then we have a sale. Life looks good. Okay. What else? Come over here. Come over here. See? Ah, we have another sale. Oh, we have another sale. So, oh, then I make a mistake. Machine 8.
Why are you not helping?
Machine 4. Enjoy. Oh, enjoy. So see, she's wearing down. The machine's overloaded, and there's what is called mean time between failures in any equipment, any person. Nobody bothers, okay? So, the dirty look I got is, in equipment terms, I'm about to fail, okay? So machine 10.
Sit here and watch me.
I'll jam this out of sequence because I got some things. And I'm ready to share. This is machine 7. Jamming this out. Luckily she has to work here. Machine 12. You have business. Ah! Do you see? Under instructions and training, nobody cares about telling me through a phone or some electronic signals like a hijinker board, hey, this is where the work stands in my work center, here's the due date, do all this. We have a sale. We have a sale. We have a sale. Yeah, we have a sale. We have another sale. Ah, let's see. So I must stand here. I'm lucky that my factory actually has a central aisle. Trust me, most factories grow like a cancer. They add buildings here, they add buildings there. Zoning constraints force them to go around the zoning constraint like a snake. Don't have this line of sight. You don't have this line of sight. Thank you.
I better be getting paid more.
Machine 9, I'm going to tell you.
Clark and I are ready more than you.
Oh, you did machine 9 already? Did you do machine 9? Okay. Okay. You got a bad part, but forgive the guy, okay? You give you a 6-pack. He ran your job.
Oh,
Yeah, man.
Thanks, man.
Please just go over those X's again. Okay?
You know, you just wanna keep doing it.
That's right. Okay, machine 11. Machine 11. Machine 11. Give me some work fine. Yes, go around. In fairness to the system, you know, because we chose the layout at random, I'm not very aware of where the equipment is. So, you know, again, you don't have to really say that, oh, this is a truly bad layout. But see some of the things that are completely wrong. No queue awareness, no production schedule, dashboard of production, poorly designed layout, no communications, no logic for how people are given work. I do my job. And so most material handlers, that's exactly what they do. We do our job because they aren't taught to worry about scheduling, about benefit rates, cost, nothing, you know. Machine 12, machine 9.
I ain't not that carpet.
That's a good point, carpal tunnel. I mean, not in this context, but the idea again is that machine failure rates depend upon usage. All machines don't wear and tear at the same rate. So depending on the work content, if you don't manage preventive maintenance programs correctly, your heavily utilized machines like 4 may be hitting failures faster than the other machines, which is bad for the company. So don't forget please that a layout also has to support communication signals for maintenance, and it should be easy for the maintenance people to go in and work around the machines, maybe move it out and repair it. Failing which, What suffers is cost of operations, work in process, and throughput. We have a sale. I don't care about that. I just want to perform on my efficiency. I need to show work being moved. I drop this part off. Then I drive back empty. There's gas coming out of my emission pipe. I'm just contributing to in-house pollution. Okay. Don't worry, not right now. Okay. That job is done. I brought back and go.
Everything I
Driving
have
again.
is like 30.
Because my handling device can only pick up a tub at a time, right? So I'm running my forklifts empty a lot, and I'm running them anyway a lot. I have a work at machine 10. There's more work for you. We have a sale. Machine 9 is a good job. We have a sale.
I gotta work this out.
Let me pick up what machine 4 did. I have to take it to machine 8. Now I know what machine 8 is. I have no idea that work is due when. So now I go later and I go pick it up again. This is machine 7. I bring it back here. See, work waits. And that's carrying cost of inventory. All that waiting cost is your engine economy, time value of money. So all the cost you accumulated on every job is carried unprocessed as inventory. And that's money not coming back to you as a sale. Bad news. So cash flow is key. This is machine 11. Fine. Again, in fairness, if they have some add-on lights or flags which might say they're ready, and if I knew, I could know what to give them. Machine 8. This is machine 7. This is machine 9. August. So my engine's running. It's kind of energy costs, pollution costs in the winter months. Forklift operation, bad news for the air quality. Oh, good place. I see some work. We have a sale. Yes. Oh! Machine! Fire this guy, I'm sorry, but respect for humans, not for coding, okay? I'm just saying, thank you. Oh, man, the real world is hard, huh? Oh, okay. The real world is hard.
Yeah, but I didn't know.
Now, again, we could fight. That's a typical mode of operation. You screwed up, no, I screwed up. You screwed up, we have a sale. Good. This would have been zero value.
Just do that and then erase the little one.
I've worked there. I've worked there.
Just do that.
You're right.
And then if you don't erase the line,
That's what I wanted to do. That's okay.
No. You can't coordinate yourselves. You are doing your job. Okay, that's not, you're being nice, but the
I
real
just
world.
think good idea.
Oh.
The next round.
There you go, we have a sale here. We have a sale here. Okay. Are we done? No, we have. Anybody still processing any work? Thank you. Right, come here. And the clock stops now. Clock stops now. Okay. Oh, we have part 11 and part 16. Anybody busy? Or maybe the performance measurement guy. Or maybe you don't have these parts. Okay, stop the clock. You can stop the clock. Well, we are trying another program, so that's too steep a curve. What did you see? What did you see about the way the system works?
I know you're about to see my workers' comp.
Okay. So here's the thing, and this is something that one team observed at one of the facilities, that there's a lot of work going into this area, and in that area, there's a lot of work going in. They're doing a lot of lifting off the floor. Okay. So high content of work, no effort was made to try and reduce that content of work. Okay. Anything else?
We had a lot of people who were standing or sitting doing nothing.
That's right. So when you have unbalanced work, you should not be paying people to be idle. So there's the waste of under-processing. There is the waste of under-processing. Now again, if you read the Ono books, they use three words, muda, mura, and muri. Muda is waste, mura is imbalance, and muri is overburden. So what they're basically saying is, not only are we wasting resources, but often there's a waste due to variability of the work being done. Okay, and on top of that, there is high workload and low workload on the people that work on the machines that run. So equipment has differential failure rates. If we don't plan a maintenance schedule, everybody talks OEE, total productive maintenance, blah, blah, blah. One of the biggest things to look for is, what's the usage rate of the equipment? And as equipment has a higher usage rate, it's accelerating faster towards failure. It's called MTBF, mean time between failures, and an MTTR is mean time to repair. So not only is there an equipment burden issue, but then there's a worker burden issue. And what they feel is that here you are going and doing 5S and other improvements when you aren't looking at the fact that I'm working harder per minute, and here are my friends discussing their last hunting trip and the football game and stuff, just because they are trained to run their machine. Okay? Now in assembly, that may not occur because the work has been balanced, they have a clear-cut tact time, and they know exactly the rate at which they should work. How many companies have that luxury? They don't. Anything else that you see? Anything else you saw? Anything else?
You just picked stuff up, there was no like, Lance, that's most money is, or like.
Absolutely. There was no information. Why? Because most company management says, why should we give our employees any fiscal knowledge? Why? Because unfortunately, the way history has worked, once employees had fiscal knowledge, they had things like the French Revolution, had people, executives being kidnapped in France when the bank meltdown occurred, right? The more knowledge is about money, and money drives behavior. Money drives people's attitudes. So a lot of people management says, why should we let people know about the value of work in process? Why should we let people know about the credit line, the borrowing rate we have? Why? Because if people can assess that there's a certain profitability approximately, they say, hey, what about incentives? Right? Unfortunately, our companies run on the basis of money. Now you can do all the waste elimination you want to kingdom come. But if ultimately you're not working profitably on the jobs that are profitable, if marketing is just being incentivized to bring work in without a true knowledge of the cost of variety, the cost of quality, you're dead. You're dead in the water. It's a very good point. The point was that theoretically in textbooks, if you read the scheduling chapters, they will say that for every job, not only do you have a due date typically, but you also have what is called OPNDD. OP stands for operation, DD stands for due date. So the program can compute for every operation, it can compute a due date. Now imagine if that information were available, then, so I'm the material handler, I have my schedule for the jobs, and then when I hit a particular work center and I see 2 jobs in queue, when I bring them over to the next work center, I look at that operational due date. Which of these jobs has an earlier due date to be completed internally so it ships on time in the shipping department? Without that computation, without that knowledge being conveyed, it was purely first in, first out. Purely keep myself busy, whatever I picked up first, I moved. Terrible way to run a business, terrible way to run a business. Like they say that in the assessments that people do, look for the number of forklifts. Look for how many forklifts they have, look for how many cranes they have, look for how many pallet jacks they have. If they're moving material, they're wasting money. Because when you move material, you batch. The cheapest form of movement is gravity. Why do you think cells work? Why do you think one-piece flow works? Because in a cell, you pretty much can make a piece and transfer it to the next work center. Okay? What else did you see?
The ergonomics that you had just picking up You use the water strike,
Yes.
picking up the material, you get it goes on the floor,
Okay.
putting it in different places.
So again, placement of the job. I mean, now, it doesn't matter much here, but again, keep in mind that typically what happens is forklifts aren't rapidly, or there are not enough of them in the shop. So when you have big containers to be moved, people start looking for pallet jacks. But see, even pallet jacks, first you have to go find them, and then you have to sort of jack them up, lift the part up. So many cases, people have scissor lifts. The whole idea again is that, why can't you keep the work at the height at which it gets to be lifted and moved, or the height at which it gets to be transferred? So, over here again, there were issues. When somebody put some work in, was there any discipline fulfilled, or just, I got an empty container, I filled it up, I don't care where it should be? So what happens typically is, the forklift people, when they come in, they have to spend that time getting into the workstation, picking up the work, and transferring it out. Now, if you read that book or that paper, Lean Material Handling, if you read the paper Lean Material Handling, when they measured the total time it takes to make a trip, they counted the time the driver took to get out of their truck, walk around the truck, go to the racks, pick up the materials, and then put them in the truck. So even things like placement of work, from an ergonomics perspective, from a time loss perspective, from a scheduling perspective, could have a final impact on the shipping deadline. Anything else?
You didn't know where you were going, so.
Exactly. I had no schedule. I just did my job. I had no schedule, so I just did my job. Why do you think that people talk about andon lights? Why do they have, if you go to Honda, they'll have a little display. Today's schedule, which is number of cars, and where we are at today. It's a simple gap analysis. Where we expect to be, where we are. And they know immediately where the entire line stands. But that's because in assembly, it's a paced system. So really, the takt time is all that that meter needs to capture. You don't have that luxury in a lot of factories. You don't have that because assembly is not relevant or prevalent in all the factories across the world. But again, there, no schedule, so completely opportunistic approach to our work. Any other observations?
In this simulation, you pretty much ran the factory dry, you started, so right now, if you had to start up either another shift or
Yes.
the end of the month, the first of the month typically, now you have people waiting to get the jobs in the system.
Yes. So, the question to you might be, you may have observed some of the work which was being done. One thought is, could you combine machines? So for example, you could take machines 3, 5, and 2, because they're used consecutively, because they're lightly loaded, you could potentially group them into a small 3-machine work cell and have one person run them. You don't fire the other 2, you don't fire them, you reallocate them. You don't fire them, you reallocate them. That's one thought. But for one thing, I can combine at least 2, 3 machine pockets. Okay? A cell is the extreme case of doing. A cell is where you put together a lot of equipment and you finish a family of products. Okay? Another important thing was, I started the system empty. You wouldn't do that. The previous shift should have put at least one job in queue at each machine as per the schedule, so that when they come in, the operators come in the next shift, they already have work in queue, and instead are not running around the place saying, hey, where's my first job? When can I start my first job? Okay? So the idea of the process layout badly done is it naturally encourages very wasteful work. Okay? So when you go to a cell layout, you will find that, again, we don't have much time today to run the cell layout. We might go through it a little bit, but you will notice that when you go to a cell layout, a lot of the inefficiencies get wiped out. So what I would ask you is, based on what you saw, the machines, I hope you'll come back Thursday. Please don't desert us, okay? But for those of you who were observing, if you saw something irrational, make a note and bring that idea to class on Thursday. Because on Thursday what we'll do is, we'll try and run the system at its very best. So if you, the machine operators, felt that you were given too much work, what we'll do is we'll say, okay, let's reduce the work you do by half on all the jobs that come to you. If you felt that certain jobs being done in sequence, we'll try and put them into a cell. So what I'll show you on Thursday is, we will take the same mix. Again, we'll run the data through fast. We'll take those outputs create what we think are two families, do a load analysis and see, hey, what does it take me to create these two cells? Run those two cells independently, completely independent, and then you'll see the difference. And if we have time, what I'll tell you is, please don't jump in and start telling people cells are the way to go. They are wasteful in their own way. So if we have time, I'll show you how jumping into purely independent cells, just because the idea looks good, is not the way to go. And you can take Storm and again design the U shape for each cell, it's all very good. But I would like to show you that, frankly, just because the textbooks say, oh, process layout is bad and cells are the way to go, cells themselves have their own implicit wastes. And so what you might want to do in the future is, hey, can I have a hybrid? So I'll show you, if we have time, I'll show you the example of something called a modular layout. This is where you have fractional cells. So there is a movement, but the modular layout is in between the process layout and the cell layout. It's much more flexible than the cell layout, not as lean as the cell layout. But it's much more lean than the process layout, but not as flexible as the process layout. Okay, because in the process layout, you pretty much say, I can do anything you give me. In the modular and the cell layouts, you're not as flexible on the mix of products you can produce. But the point is, fundamentally the point is, if you design the layout bad, if you choose the wrong mix of products, wrong sequences of production, you don't balance the workflow, poor handling, no visual communication, no performance metrics, poor cross-training of employees, you essentially have a messy factory, a bad factory. So the layout starts you thinking on all the best practices you can bring to bear. But it's not a solution by itself. There's a lot more that you will have to do. So my request to you, please, is keep that machine tag with you. Just please keep the machine tag with you. Just keep it for one more day. And if you're coming back, we'll get together again on Thursday, and we'll run two cells. And I want you to then look at that and say, hey, what is best? Thank you.